Welcome back to the video series on Math Revision Made Meticulous, Day 14, Integration by Parts. Revision, as the name suggests, means looking back over previously learned information, ensuring that it is clear and fresh in the mind. 5 questions per day from selected topic is presented at this video series. The steps in answers are supported by the ideas used for getting the answer. Integration by parts. We take u and v are two differentiable functions and we visualize the integral as a product of u and dv. First function into derivative of the second function. Then to integrate it, the answer is uv minus integral v du. U into v, first function into second function, minus integral second function into differentiation of the first function. Now how to do it? First identify the function u. The remaining function will be taken as dv. Differentiate u to get du and integrate dv to get v. We will always take u in such a way that you can find du. Then put it in the formula uv minus integral v du. That the right hand side integral v du will be easy for you to do. It will become under a standard form or normal form which you have already seen. Let us now go to the next type where we find the combination of trigonometric function and exponential. Always remember exponential should be given the last preference. For take u as the trigonometric function. Suppose you have integral e power x sin x dx, which is trigonometric function sin x. Take it as u. Remaining will be taken as e power x dx. Here, which is the trigonometric function? Sin square x. Take u as sin square x, dv as e power 2x dx. Here, the trigonometric function is cos cube x. Take it as u and the remaining as dv. For whenever you have the combination trigonometric function and the exponential function, you have to take u as the trigonometric function and the exponential function and dx will be dv. But let us go on to moving on a problem now. Here, in all the problem involving trigonometric function and exponential function, we have to repeat integration by parts twice. Because sine will become cos. If you do once again, cos will become sine and you can bring it to the left hand side and you can finish the problem. Integration by parts will be applied twice. As usual, take u as the sin x, dv as e power x. You know du is cos x dx and v is integral e power x into dx, which is e power x. Put it in uv minus integral v du form. What is u? Sin x. E power x is v. Therefore, e power x into sin x minus integral v du e power x into cos x dx. Now you end up with on the right hand side e power x into cos x dx. Once again, it is a integral involving trigonometry and exponential. Continue with the same thing, which to be taken as u cos x. dv is e power x, du is minus sin x dx and v is e power x. Now for the second integral, again put it in the form uv minus integral v du. Therefore e power x into cos x minus of integral e power x, that is v into du minus sin x dx. Minus into minus will be plus. Once again there is a minus outside. Therefore e power x sin x minus e power x cos x minus integral e power x sin x dx. Already you are having one e power x sin x dx in the left hand side. Bring the right hand side integral to the left. You can add it. You will get 2 into divide by the right hand side. Therefore the final answer is half into e power x into sin x minus cos x. That idea is very simple. If you start with e power x into any trigonometric function, it may be sin or cos, do the integration by parts twice, you will get back the same integral on the right hand side. With some constant multiplied, bring it to the left hand side and finish. Let us go to the next problem. E power 2x into cos 3x dx. Same technique. Take u as cos 3x, dv as e power 2x. Here be careful with the constants which which is coming out. du is minus 3 sin x dx, v is e power 2x upon 2. Now let us put it in uv minus integral v du form. U into v, therefore e power 2x by 2 into cos 3x minus integral v du e power 2x by 2 into minus 3 sin x into dx. Minus into minus will become plus. I am taking the constant outside. For e power 2x upon 2 by cos 3x plus 3 by 2 into integral e power 2x into sin 3x. The integral which is on the right hand side is once again exponential and trigonometry. Therefore, once again put u is equal to sin 3x, dv is equal to e power 2x, du is 3 cos x cos 3x dx, and dv is e power 2x upon 2. Carefully let us put it inside the integral sign now. First term is e power 2x by 2 cos 3x. The second integral will be 3 by 2 into u into v, therefore e power 2x by 2 into sin 3x minus integral v du e power 2x by 2 into 3 cos 3x. Carefully let us take all the constants outside. It will be e power 2x by 2 cos 3x plus 3 by 2 into e power 2x by 2 sin 3. I am expanding the bracket. Minus 3 by 2 into 2, 1 by 2, it's 9 by 4. Therefore it is minus integral e power 2x into cos 3. That is a constant outside. 3 by 2 into 3 by 2 is 9 by 4. Now bring that e power 2x cos 3x multiplied by 9 by 4, which is on the right hand side to the left hand side, it will become plus 9 by 4. So we are getting the remaining terms there. Therefore we end up with this term. Therefore what we can do now, integral e power 2x cos 3x can be taken outside. It will become 1 plus 9 by 4. On the right hand side I am taking e power 2x, I am taking LCM. Therefore e power 2x LCM is 4, therefore I am multiplying and dividing by 2 to take e power 2x common. E power 2x by a number common. Okay, it is 13 by 4 into integral e power 2x cos 3x is equal to e power 2x by 4. When you take it outside, it is 2 cos 3x plus 3 sin 3x. Bring that 13 by 4 to the right hand side, it will become 4 by 13. For final answer is e power 2x by 13 into 2 cos 3x plus 3 sin 3x plus c. So here the same technique, we have applied integration by parts twice. Now sometimes the trigonometry function may be given in some other form. Instead of given directly sin 3x, directly cos 3x, it is e power x into sin x cos x. But all of you know 2 sin x cos x formula we know. It is sin 2x. Therefore multiply and divide by 2. It will become integral e power x into 2 sin x cos x by 2. Now it will become e power x into sin 2x into dx. Now we are getting a exponential in the trigonometry. Let us consider it separately. Same technique, u take it as sin 2x, dv as e power x, du as 2 cos 2x, and v as e power x. But when you put it in the integral sign, uv sin 2x into e power x minus integral e power x into 2 cos 2. Let us continue. Integral e power x sin 2x minus integral e power x into 2 cos 2x dx. Take 2 outside. Therefore now once again you are getting an integral on the right hand side, exponential and trigonometry. U is cos 2x, dv is e power x, du is minus 2 sin x 2x, and v is integral e power x into dx, which is e power x. Well, now put it inside the bracket. Now the integral is u into v e power x into cos 2x minus e power x into integral e power x into minus 2 sin 2x into dx. Now bringing the minus sign inside, it will be minus into minus is plus, therefore once again there is a minus outside, therefore minus 2 into e power x cos 2x minus 4 into the integral. Now as usual we are getting the same integral on the right hand side. Bring that minus 4 into that integral to the left hand side, it will become plus 4 into the integral. The right hand side is e power x into sin 2x minus 2 into e power x into cos 2x. For 1 plus 4 is 5. Bring that 5 to the right hand side. So you will get integral e power x sin 2x is 1 by 5 into e power x into sin 2x minus 2 into e power x cos 2x. But we started with this integral e power x sin x cos x. What is it? 1 by 2 into the integral e power x sin 2x by dx. But now once again divide the right hand side by 2, you will get 1 by 10. So the answer is 1 by 10 into e power x into sin 2x minus 2 cos 2x. But we started with e power x sin x cos x, but we have done integral e power x sin 2x and divided by 2. Good. Let's go to the next problem, where it is e power x into sin square. It may be e power x into cos square, e power x into sin square, anything may be. Now we will take u as sin square, dv as e power x, du is 2 sin x cos x, and v is e power x. But now what is this du? It is nothing but sin 2x. 2 sin x cos x is sin 2x. Therefore du is sin 2x dx. Or what will be the problem now? U into V e power x into sin square x minus integral V du e power x into sin 2x. Now remember, this e power x sin 2x already we have seen in the previous question, where we can directly substitute that answer here. But anyway, you have to do it separately in the exam. But as we already seen, I am directly taking the answer minus 1 by 5 into e power x into sin 2x minus 2 into e power x into cos 2x. I have taken directly from the previous step. Let us move on to question number 5. We move on to the question number 5. Evaluate integral sin log x dx. We can't do this problem directly because there is no formula for sin log x dx. But we can convert it into exponential and trigonometry by taking the substitution t as log x. X will be e power t by rising to the power of e both sides. But dt will be dx upon x as t is equal to log x. Now what is dx now? X dt. Therefore dx is equal to e power t into dt. E power t dt. Substitute now sin of log x into dx. Sin log x is sin t and dx is e power t dt. Here we end up with a problem where it is exponential and trigonometry. U is sin t, trigonometric function, dv is the remaining, du is cos t dt and v is e power t. Put it in the formula now, it will become e power t sin t minus e power t cos t into dt. Now we are just writing it once again, e power t into sin t minus e power t into cos t dt. L. We end up with this once again. This to be tackled using integration by parts by taking u as cos and dv as e power t. Once again you are getting du as minus sin t and v as e power t. Put it inside that integral now, minus of u into v. Therefore e power t into cos t minus integral v du e power t into minus sin t dt. And when you expand the bracket, minus into minus into minus, therefore minus. Now that should be brought to the left hand side. Therefore you will get 2 times, for you have to divide it. For integral e power t sin t is half into e power t into sin t minus cos t. But we started with integral sin log x. Therefore where we substituted t is equal to log x and started the problem. Therefore replace t as log x. For it will become half into e power log x into sin of log x minus cos of log x plus c. Now we have seen a lot of problems involving exponential and trigonometry, but there is a direct formula for integral e power x ax into sin bx dx. This formula is derived by using the same technique, integration by parts twice, but this formula can be remembered by you to check the answer after you have calculated or evaluated the integral. E power ax sin bx is e power ax by a square plus b square into a sin bx minus b cos bx. Similarly, integral e power ax into cos bx is e power ax by a square plus b square into a cos bx plus b sin bx plus c. Success is dependent on effort. All the best. Thank you.